Hi everybody, this is Mrs. Snowbeck. Today we are going to do section 2.3, proving lines are parallel using converses. And you might be wondering, what's a converse? It's when you take two parts of a sentence and flip them around. For instance, if you are 16, then you can drive. The converse of that is, if you can drive, then you are 16. So this first one says, if two lines are cut by a transversal. So what I'm going to do is I'm going to go ahead and draw two lines, and they're going to look like they're parallel, and they're going to be cut by a transversal. I'm going to call the lines A and B. And then it says, if you have two lines and they're cut by a transversal, the corresponding angles are congruent. So like for instance, these angles right here, angles 1 and 2, if those are congruent, then the lines have to be parallel. Well, in the last lesson, what we learned is if the lines are parallel, the corresponding angles are congruent. Today, we're learning the converse. If the corresponding angles are congruent, then the lines are parallel. So we can say if angle 1 is congruent to angle 2, then A is parallel to B. Number 2, the converse of the alternate interior angles theorem. Again, draw your two lines and draw a transversal cutting through. Call the first two lines A and B. And this time we're going to mark these two angles, 1 and 2, because we're going to work with alternate interior angles. And it says this: if two lines are cut by a transversal and a pair of alternate interior angles are congruent, then the lines are parallel. So if we know these two angles right here are congruent, then A would have to be parallel to B. If angle 1 is congruent to angle 2, then A is parallel to B. Number 3, if two lines are cut by a transversal, so same picture, we'll label A and B, but this time we're going to mark angles 1 and 2 out here as alternate exterior angles. So if your two lines are cut by a transversal and the alternate exterior angles are congruent, then the lines are parallel. So if angle 1 is congruent to angle 2, then for sure A is parallel to B. Number 4, go ahead and draw the same picture. This time we're going to work with consecutive interior angles. So I'm going to put my 1 and 2 right here. If two lines are cut by a transversal and a pair of consecutive interior angles are supplementary, then the lines are parallel. So if you figure out these two angles are supplementary, so in other words, if angle 1 plus angle 2 equal 180 degrees, then A is parallel to B. I guess we better label our A and our B. So in this case, the two angles add up to 180. If they add up to 179, nope, the lines are not parallel. Number 5, if two lines are perpendicular to the same line, then the lines are parallel. Okay, go ahead and draw your two lines, but this time when you draw your transversal, you want it to be perpendicular to the two lines. So we can still label A and B. In fact, let's label this other line C this time. So if you see something like this, and if A is perpendicular to C, and B is also perpendicular to C, if they both meet C at 90 degrees, then A is parallel to B. Then the two lines would be parallel. Remember that upside down T means perpendicular. And our last one, number 6, if you're given a line and a point not on a line, let's draw that. Here's a line, we'll call that A, And here's a point, we'll call that P, and P is not on A. So if given a line and a point not on the line, then there exists one line through the point that is parallel to the given line. A question might be, how many lines can I draw through P that would be parallel to A? The answer is only one line. Only one line would be parallel to line A. Next, let's put an A, a B, and a C here, and let's put a D up here. Number 1, is it possible to prove any lines parallel if angle 1 is congruent to angle 3? All right, here's angle 1, here's angle 3. If we know they are congruent, do any lines have to be parallel? The answer is yes. A would have to be parallel to B, because those are corresponding angles. And if the corresponding angles are congruent, the lines would be parallel. Number 2, find the measure of angle ZYN. So ZYN is right here. We want to find that angle measure so that line PQ and line MN are parallel. Well, line PQ is this one, line MN is this one. If we want those to be parallel, then we want these two alternate exterior angles to be congruent. This is number 3 of the postulates and theorems that we did at the beginning there. So if we want the lines to be parallel, these have to be congruent. So I would do something like 11x minus 25 would have to equal 7x plus 35. And then you quickly solve your equation. So go ahead and do that. Okay, and when you're done, check if you got the same thing for x that I got. But the question says find the measure of angle ZYN. So when you're done, you're going to have to substitute that in. The measure of angle ZYN is going to equal 7 times 15 plus 35. That's 105 plus 35, which is 140. And that would be the size of the angle if the lines are parallel. Last one, number 3, find x so that m is parallel to n. Go ahead and pause the video and try to set up this equation. If we want those lines to be parallel, these two angles will have to add up to 180. They have to be supplementary. So your equation should have looked like this. 3x plus 14 plus 5x minus 10 equals 180. We have 8x plus 4 equals 180 minus your 4. We have 8x equals 176. And I think, I don't have a calculator right here, but I think it is 22. So correct me if I'm wrong on that one. Hopefully I'm right. That's it. Will you please try Unit 2, Practice 3. Have a great day.